Hello my friends, happy sciencing again. Here I am presenting you my another video after the vectors, that is the kinematics. Believe me guys, there are lots of formulas right here. There are lots and lots of formulas. So now I'm starting with the graph analysis of the kinematics. What does the first graph analysis says? Now let's just carry on my guys. Displacement time graph. Now displacement time graph, let me explain you. The displacement time graph be any graph where on the x-axis and y-axis which gives us the variation of the displacement versus time. Time is mostly on the x-axis, so I'm writing here, and the displacement. S starts for the displacement, T starts from time. Now it may give anything like this gives the variation of displacement and time. Then the slope of the tangent gives us the velocity. Now let us take any point A. Alright guys. Now from the A I am drawing a tangent. Then the slope of the tangent, that is tan theta, is equals to velocity. This gives us the velocity in displacement time graph. And now our next graph, velocity time graph. The graph that shows the variation of the velocity with time. Let me draw it again. This be time, then this be velocity. Now let the velocity be varying as time like this. Then slope gives instantaneous acceleration. As you can see, I've written it in my notes. The slope that would give me instantaneous acceleration from any point A. And if I want to find displacement, that is in this velocity time graph, you can now observe the graph in time t. Let the time be this thing. Let the time be t0. If you want to find the displacement, then area under this curve can show you the displacement traveled by that object till the time t0. Now let's get on to our next thing, that is acceleration time graph. Now let the acceleration time graph be like this. This is time, this is acceleration. Acceleration gives us let the acceleration be varying like this, any other shape. Then area will give dv, or change in velocity, like in this is t0 and this is t1. Then area, this area would give us the change in velocity from this point to this point. Alright guys, so this is the acceleration time graph. And now let's move on to our next topic, that is the calculus approach. What does the calculus approach says? When acceleration is the function of time, that is when a equals to ft, where f is the function, or I must say a is equals to f of t, where a is the acceleration and t is time. And f be any function, of course you must know what is a function. And if acceleration is function of time, then simply, now please don't say that you don't know the Newton's kinematic equations, that is v equals u plus at. Then by integration you can see that v equals to u plus integral ranging from 0 to t ft dt. v equals to u plus a t. This can be the calculus approach when acceleration is the function of time, that is when a equals to ft. Now let's move on to our next page. When acceleration is the function of displacement, this is our new topic. When v into dv by dt is equals to function of displacement, where x is the displacement. Then by using our another mechanical formula, v square equals to u square plus 2as, v square equals to u square plus 2as, ranging from 0 to s to as. This is when acceleration is the function of displacement. And now our next topic, when acceleration is the function of velocity, a equals to f of v. Then you have to remember these asshole formulas, that is, the first formula is time equals to integral ranging from initial velocity to final velocity dv upon fv. that is 1 upon function of velocity into dv. Okay, time equals integral ranging from initial to final velocity, 1 upon function of velocity dv. At next motherfucking formula is x equals to x naught. X is the displacement, x naught is the initial displacement. X equals x naught plus integral ranging from u to v upon fv dv, where fv is the function of velocity, or we can say f is the acceleration. I is equal to fv, as you can see right here. Now folks, our next topic, the projectile motion. Now first let me tell you what the fuck is the projectile motion. So now let me tell you that if this is a ground, okay, ground, simple ground, a man is standing here, he has a ball in his hand and he throws the ball upwards. Then please don't expect that that ball will just go into space. It's not like that. The ball goes like here, goes to its highest height and falls again, where this is h and this is the range. Now first let me tell you the formula of the projectile motion. Forget this part, and now first let us say the formula. If h is height, r is range, this is theta. Theta is the angle of projection. We can call it the angle of projection. Then what is the formula for height? H max equals to u square sine square theta upon 2g is the formula for height. The formula for range is u square sine of 2 theta, so sine of 2 theta upon g. G is the acceleration due to gravity, where g equals to 9.8. You can say sine 2 theta, okay, sine of 2 times the angle of projection. I'm not gonna derive this all fucking thing, because you have to remember this formula, because when you're writing the exam, nobody's gonna whisper, hey mister, the formula of projectile is u square sine 2 theta upon g. Nobody's going to do like that, because you have to remember this. So I'm sorry. And the time is equals time taking for projectile from this position to this position equals to 2u sine theta upon g, where and from this position to this position it would be u sine theta upon g. Alright, just remember what I hear. Okay, from here the velocity is divided into this component, y component, and x component. At this maximum position it is just x component, and at this position it is divided in again x component and y component, but y is negative. Resultant is always the same. Alright, if you would see my last video on vectors, then you would know what is resultant and what the hell is x component, y component, and all that. Let's get on with the cases of the projectile. Now let's come to this. Case 1 of the projectile motion, that is, if any person is standing at a tower of height h, this is the tower of height h, and he has thrown a ball on height h to a straight line. He has thrown a ball straight away with a velocity v. And what would be the angle? Angle here would be theta. This would be angle of depression, and the range of the projectile would be, of course, r. R would be the range. The ball falls like this and goes somewhere in the ground and follows the range of r. The height of tower is h. Then remember the formula. Then the time taken for the projectile from here to here is under root of 2 times height upon g. G is 10, so 2h upon 5. Don't remember this formula especially. Time would be under root of 2 times the height upon g. What would be the range now? The range would be now, just he has thrown the ball right here, the ball has ended up here. This is the range. The formula for range is, of course, displacement. Displacement is equals to velocity into time, v root of 2h upon g is the formula for the range. Displacement is the range, velocity, and then this time. So displacement equals to velocity into time. Now getting over our next page, another case, another idiotic case. Projectile at theta above the horizontal. Again, let this be any person. He is just throwing a ball above the ground, above the plane, or above the tower where he's standing by an angle theta. Then it could follow the path like this. like this it would go, and then from some maximum height it would fall down and come over a range R. So then the equation for this is minus of h equals to minus of height is equals to u sine theta t minus half gt square is the equation of trajectory. By applying the formulas or by applying the values, you can get each and every value you desire. But by that we can just desire that you have to remember this formula. Actually very important formula, guys. Actually, yes, it is important. Time equals to u sine theta upon g plus or minus under root of u square sine square theta upon g square plus 2h upon g. 2h upon g is the time for this, but the time for this would be u square sine square theta upon g square plus 2h upon g. Okay, so this was the actual time on u sine theta upon g plus or minus this all. And now let's get over to our next case, that is theta below in the angle theta, and a person is standing right here. He's thrown a ball or something below the tower by the angle theta. Then what would the equation of trajectory? Minus of h is equals to minus of u sine theta t minus half gt square. Now remember, guys, for this case the equation of trajectory is minus of h is equals to plus u sine theta t minus half gt square. Here is minus of h is equals to minus of u sine theta t minus half gt square. The time taken for this to reach here, minus of 2 u sine theta. You can note down anywhere or wherever you like, but this formula is really very useful. Minus of 2 u sine theta t, or minus of 2 u sine theta plus or minus under root of 4v square sine square theta plus 8gh upon 2g. Remember this formula, guys. You have to actually, but if you're writing a paper somewhere and this question comes up, a man throws up, then it would be a simple formula sum. But what would be the problem? What would be the problem with you that you don't know the formula? And I hope you won't have the time to derive the formula at the exam, as exam is time limited. So guys, it's the worst truth that you have to remember the formula. Because if at exam it comes that if a person is standing here, he throws the ball right here, the ball goes, then find the range and find the time. Then you would know, oh, this was the projectile motion formula. You would know, and you would also know that this was a simple formula based question. But the only problem is you don't know the formula. So guys, you have to remember the formula. Let's get on to our next page. Next page is relative motion. Relative motion, a very, very, very important part of the kinematics. The relative motion. The first problem is the river problems. River problems. Now suppose this is the bank of the river and this is another bank. I must have darkened it, but I didn't. I'm sorry, guys. These are the two banks of the river. A person is velocity of boat. We must say a boat is going from, like, in this direction. This velocity of boat with respect to river, VBR, and it is going at an angle. This is the normal drawn from the bank of the river, and this is the angle theta. So velocity of boat with respect to river is VBR. It is the velocity of boat. It makes an angle theta. The flow of river is towards this direction. This is the velocity vector VR. Then what would be the time? Time is equal to width of the river. This is the width. W upon VBR cos theta would be the time to go from this bank to this bank of the river. Further displacement as it causes the bank. So now this is our next formula. Further displacement as it causes the bank. So in this formula I must draw a next diagram for it, that if these are the banks of the river, a man is going straight away here, or I must say that, okay, further displacement we have cos theta right here. So further, what is the further displacement? As the flow of river is this, so if the man in this direction is the flow of river, so if the man gets an angle theta and goes straight away like here in this direction, then due to the river flow he would come here somewhere. He could not, it's not possible for him to reach at exactly this position if he goes right there, because the flow of river is in this side. So he must be drifted here, and he must be drifted here somewhere, and the direction would be changed. So what would be the further displacement? That is, if there was no flow of river, this man should reach here, but as there is flow of river, this man reaches here somewhere. Then this x is the further displacement. The formula for the further displacement is x is equals to velocity of river minus velocity of boat with respect to river sine theta. VR minus VBR sine theta into the width of the river, W upon VBR cos theta. W upon VBR cos theta is the time, and VR minus VBR sine theta is the relative velocity. Displacement equals to velocity into time. Displacement equals to velocity into time. Velocity is velocity of river minus velocity of boat with respect of the river sine theta into W upon VBR cos theta, which is the time. And now another condition, it comes every fucking condition we have to just remember, because guys, it's an exam, you have to excel. Displacement is velocity into time, you can note down it somewhere. And now another, to cross in the shortest time, that is, we want to cross the river if someone is in hurry and we have to just go across the river in the shortest possible time, then what would be the time? Minimum time is equal to W upon VBR. For minimum time, the cos theta should be 1, that is theta should be 0, that is if he goes like this, then he would cross the river in the minimum time, that is W upon VBR. And if boatsmen want to reach an exact position at the opposite bank, I don't know why would boatsmen like to do this, but I don't know why would boatsmen would like to do this, but I don't know why. It is a formula, so you have to learn. So if a boatsman wants to reach exact at this position after drifting from the river, then what angle would she go? If it's angle theta, it goes right here, goes due to flow of river and reaches here. Then what would be the theta? Theta minimum is sine inverse of VR upon VBR, velocity of river upon velocity of boat with respect to river. That means sine theta equals VR upon VBR. So guys, this is the theta, the value of theta for which the boatsman would reach as the exact opposite point. So guys, thank you for watching. Here we can end our kinematics. I know I didn't take the one-dimensional motion because those were actually formula based. These were the most important and the most weighted chapters of the kinematics. So I'm sorry, and even the video is quite long. So guys, please tell me how was the video in the comments, and what should I improve in my video. Please tell me what the hell should I improve in my video, because I want to improve. And if you like this, and if you find this video even 1% informative, then please like and subscribe my video, and please tell me how should I improve. I would definitely just do whatever you say in the comments. So thank you guys, see you in my next video. Thank you very much. Happy sciencing.